Good morning. Okay. Now I can start. Appears to be last lecture for this course. Yeah. What I'm about today? Auto reclosing. Think very helpful and useful thing. Auto reclosing. What I'm about? See, faults occur. Oh, different kind of faults can occur. But statistics is a harsh thing. And statistics show that about 70% of faults are, transient. They are not stable. Tree falling, all kind of object, insulation, flashover. All this kind of faults are not persistent. It's not like fallen tower, or I saw it in person, large digger drawn into line. Transporters didn't bother to measure height of the digger. It's a persistent fault, but most faults are transient, really about 70%. That means what after some time we can successfully put our line back into operation. What time? What's time? First, we need to wait while arc channel deionized. How faults occur? For example, tree is falling on the line. It burns. Arc channel of highly ionized gas forming. We have a short current. We disconnect line. What happens? Arc channel dissipates. And insulation reestablished. We can switch our line back into operation without any problem. Same thing. It's regular. It's a disease. Young hooligans throw thin wires on the line. Oh, it's funny. Wire burns. Arc channel. If we interrupt current, arc channel dissipates, cools, deionizes, and we can switch line back. Large burns do pollute insulators. All this, pollution burns out, give it time to cool down, and you can switch line back. A lot of transients. These faults, they are transient, not stable. So give time, give some second for arc channel to dissipate, and you can switch line back. Also, we need to give some time for switch to cool down. Our circuit breaker can be operated virtually instantly in parts of seconds. Some older design needs a time to cool down. So we cannot switch back in time shorter when time required for switch to switch chambers to cool down. But if we take a look on net segment, what will be our strategy? Maybe I'll draw it like this. Auto reclosing time. Auto reclosing. When it should be shortest? At the supply. We should think in which way? In the way of, okay, resilience isn't the best word here, in the way of safety. In case we had for example, fault was here, but we had problem with this relay and operated backup protection. This means that it's possible that all the switches are disconnected. It's a bad selectivity, but sometimes it happens. One more thing. Many network operators do prefer installation of minimal voltage protection. It's done, first it prevents stability disruption called voltage avalanche. When you have large, really serious penetration of industrial load, it can be a situation when you have deficit of reactive power, and if asynchronous machines are put in under voltage condition, they start to consume reactive power aggressively. This causes future voltage drop and more consumption of reactive power. So it's a process with positive feedback, and it causes a problem. To prevent it, minimal voltage protections installed, which drops customers if voltage is below 80-85% of nominal. One thing. Another, many network operators do adopt policy of safety. Not creating a backup channel for case current protection fault. One of the driving factors, if we have so-called reclosers, it's I have one in 4.4. Recloser is a device can be put on pole. It's a circuit breaker, simple overcurrent relay for classical reclosers. Modern are equipped with quite sophisticated relay, all kind of protection, basic set of protection on your disposal, and see, we are very conservative in our design approach. So reclosers may fail. One of the things may happen. Old types of reclosers are prone to freeze. During the very cold winter, they freeze and can misoperate. So as a backup, one thing can be done: minimum voltage protection. In case of fault, voltage drops seriously, and this acts as one more backup stage. So in case, what will happen? For example, we had fault here, this switch disconnects, but all forward going will also be disconnected by minimal voltage protection. We need to restart network, and it's done by auto reclosing. I don't like such designs where everything should be corrected by auto reclosing. We can omit selectivity because auto reclosing will cover everything. I don't like this approach, but it exists in reality. Allowing non-selective operation, auto reclosing will do our work. switch this one. 1, 2, 3. With step approximately 1 second. So after fault cleared, first segment will go back in 1 second. Sometimes time is taken short. This one in 2 seconds, in 3 seconds. Boom, boom, boom. They will be switched back. If fault is persistent, as I showed, first segment switch without problem, second segment switch on fault immediately, disconnected and everything stops. If we try to go backward, nothing will happen. What will happen? Bad thing will happen. We will get again switch on fault, but in less favorable position. Also, one more thing. Not always. In general, most will. For example, this tiny guy. It's a 24 kilo simply. Then we disconnect. See? It has enough energy in its spring for full cycle. Disconnect, reclosing, disconnect. Now spring energy is depleted. I need to get it back online. Now it will recharge. Yeah, spring recharge. Ready to operate. Spring recharge. Switch on. Some switch need power to reconnect. This one, good models have enough energy in their springs, but cheaper model can only disconnect and wait. They will not operate until here at buses voltage arrives. It's also driver to go this way from the power source. If we have power from both sides, it will be tricky one. It's more complex reclosing. Okay, so idea how auto reclosing should operate. It should switch line back after time delay if line was disconnected by protection. Manual operation should not trigger auto reclosing. Yeah? And another one, it should operate limited number of time. Otherwise, we have persistent fault, disconnection, reclosing, fault do not disappear. What happens? Okay, protection acts, switch disconnected. Can we allow reclosing? No. Okay, 2 times may be allowed, but not more. Because if more, our switch will blow. We will switch on fault multiple times. For reclosing logic, number of operations should be limited. 1 or 2, 2 is enough. Third one will be when dispatch guy tries to switch line on. So, operation only if disconnection was by protection signal, limited number of operational tries. That's what we needed. Now I can start to speak about inner logic of reclosing. Where are you? use overcolor. Where is my reclosing color? And you again overcolor. Reclosing railway. Oh, here you go. Here, where am I? Here. This one is a old school reclosing railway. As I understand, in 1958 model, still some still in operation. Very successful design. Inexpensive, relatively, extremely robust, and what was good, it's very fault tolerant. Oh, this, what it has inside? Clockwork to set delay before reconnection. One nice tiny interim relay, and what else? This green resistor and one paper or capacitor. Nice tiny relay. One moment. I would like to use it as an example of reclosing logic. It's a good example to understand how it should be done. Of course, nowadays it will be digital relay, but internal logic of process. Sometimes what nope, this is wrong, this is wrong, this is wrong, this one. Oh, yeah. 1 second, I will get my video. Oh, yeah. Here is picture from its near original manual. It's from it's from this 1962 description, but it's very close to original manual. Here is circuits of outer reclosing with this relay. I will not go deep into design, but what's basics? This nice block. Sorry, here it is. One. I don't have I don't know. It's disappeared. I have it, but it's somewhere. This is not original. This is second stage of control switch. This block is control switch, and control switch for this application are interesting. They have 4 positions: 2 locked and 2 spring loaded with release. Locked, locked, spring loaded. It's done firstly as a safety measure. You cannot connect or disconnect line without putting a switch first in the stable closed or open position. So this position, switch off, and only this will give a command. You need to prepare circuit. This prevents operation from some kind of disturbance. It's one of the measurements to prevent false operation. Signal to connect line or disconnect line can only be passed if we have line under operation, switch is on. This is line on position or something, I don't know, transformer on position. To disconnect line, you need to first put switch into position disconnect and then send a command. So, idea. This relay compares state of the switch. Line should be on, line should be off. With state of the circuit breaker. If there is a difference, so switch in position, in this, switch in vertical operation, switch in vertical position, line should be on. If here to this circuit arrives a signal from protection, disconnect line, it goes through coil circuit of interim relay, through this is internal contact of circuit breaker and disconnection coil of circuit breaker. Relay, this relay will I will explain why this relay works. So if switch in position operate and signal from protection comes, what will happen? This 5-4 circuit is closed when switch in vertical position. Line should be on, but it is off. What will happen? Happen this thing. Voltage arrives here. It goes. It goes to because this will be energized. This circuit is closed and we have voltage here. Okay, this should activate our time relay. This time relay should be activated, and when 1 second, yeah. I'm getting cold. This circuit. What this is interesting circuit. This interesting idea. This one is how can you see it? It's a disconnection coil of my circuit breaker. This contact is inner of the circuit breaker. Where is the point? These control coils of circuit breakers. They are not thermally resistant. They cannot. They can remain under voltage only for some 5 seconds. Circuit breaker has a built-in set of contacts connected with in series with this coil. They are inside. I should take off the cover. So, what's done? Small current relay, resistance, and current flows through this relay, through the coil. This circuit checks if the coil is available for operation. To operate, this coil requires from 2 to 5 amperes, and this resistor limits in some 200, 300 milliamps. Current in this circuit is insufficient to operate a circuit breaker, but this circuit acts as a control what circuit breakers connection control circuit is ready for operation. Without it, nothing happens. This relay, this nice relay, look here, will not try to operate damaged breaker. Only if on circuit wait, no, this one. Oh, this relay. Only if connection circuit is available, auto reclosing will send it signal. This can be used. See, SF6 breakers have and compressed air circuit breakers. They have a circuit pressure sufficient. They are. It's dangerous to operate such kind of switch without sufficient gas pressure or air pressure inside. So here also sits signal pressure sufficient. Okay, if switch is ready, actually this circuit, this is the circuit, checks switch ready. When switch is ready, this contact is closed, and through this net, this one, 5-4, is closed when it's in vertical position. Through 5-4 closed, through when this contact is closed, when switch is disconnected, ready to be switched on. This means if switch is ready to be switched on, this means that our switch is now in off position. Switch in off position, we are ready to switch on. What state of the control switch do not correspond to state of circuit breaker. It's a how to say, reason or driving signal for reclosing. Current will go here, activate this timer relay. This thing is for thermal resistance. When time relay counts, happens next thing. Remember I showed with finger oil, paper or capacitor. This capacitor is charged through this resistor to the operation voltage. At the moment this time delay contacts close, capacitor is discharged to interim relay number 2. Interim number 2 closes, and first what it connects, it has two coils, one voltage, one current. Capacitor discharges through voltage channel. This contact closes and connects current coil to this voltage source. We have plus here. Through signal relay auto reclosing, it goes where? It goes here through this relay number 3. Relay goes here to relay number 3 and also goes through this circuit to connection. Boom, our switch connects. What's the idea behind this RC circuit? At the first moment, capacitor will, at the first operational of auto reclosing, capacitor will be charged. And what will be happen when we have disconnect, we had disconnect, connect, but we have switch on fault. Again, disconnection command should be auto reclosing, but capacitor is not charged. This RC circuit is a very basic timer. And it says what auto reclosing is possible only with some time delay of switch should remain on for time until this capacitor charges. Actually, it's a single action. This basic timer ensures single action. There will be no second auto reclosing. If we have switch on fault, immediate disconnect, this capacitor will be discharged, this is going to be discharged, but this circuit, it's an inhibit. In case you, for example, insufficient pressure or over temperature, switch overheat. In case switch overheat, this circuit can be used as inhibit. There will be no auto reclosing if you activate this button, contact. Also, what's here? One more interesting thing. For example, what I would like to say, for example, we have an idiot on duty. And what happens? We have a persistent fault. For example, earth link left on line. Our idiot came and pushed connect. Do it, connect. What happens? Switch on, persistent fault, protection off, and what then? Auto closing will be forbidden. If switch is in on position, this circuit will be disconnected. But that's not all. See, this circuit, this one is circuit to switch. Here 1, 2, and this 1, 2 are closing when I push. Do it. Connect me. 1, 2 goes through. Sorry. 1, 2 is disconnect. Sorry. 1, 3. 1, 3 will be closed. When 1, 3 is closed, but what will happen? After signal arrives, third relay will remain in on position until, because 5-4 is closed and we had signal, the relay 3 will be on, and to disconnect it, if 1, 3 on, this one prevents sending of on signal until switch is put to off position. It's a special logic. On command can be sent before off command. You can you can send on command only once. Once, if it wasn't successful, you will be able to send it again often, only after you put your switch in off position. Then you need to go on and put it again. Okay. You could say it's archaic. Hey, come on. Come on, I need this one. Oh. Here, here is modern incarnation of same logic. One of the problems with original P58, it requires switch. Signal to reconnect line, how to say, emerges on what condition? State of the control switch is compared to state of circuit breaker. Yeah? But if we have dispatch control or remote control, there will be no signal from the switch, from the control handle. Some system had implemented a solution. Solution, where are you? Where is my? Should be somewhere here. Quick clock relay, where are you? Quick clocks, where are you? Somewhere. Who's here? Solution was found as memory relay. Where is it? Where is my memory relay? 1 second. There is one. Everything disappears. Who's here? Disappeared. It's clearly abduction case. Sit somewhere and drowse. Stupid railway. Here it is. I'm getting cold. It's on a visible. Here it is. Trigger relay. Two position relay. It has two coils. If you send voltage to one, it switch and stay in this position. If you send voltage to another one, it switch and remain in this position. Actually, it's a memory for 1 bit. Mechanical. Quick and still. Quick. This relay was used to remember last command sent to the circuit breaker. So, on or off. Mechanical memory, electromechanical memory, for only 1 bit. So, what I got here? I show as a control button. Actually, it may be output from dispatch system. Go on or go off. Off signal or signal from protection, anyway, or goes as off command and disconnect our circuit breaker. Trigger, this one is a memory of last command. It was on or off. If last command was on, here will remain 1. Should be on state. From the state of circuit breaker is compared with the last sent command in 2 ways. Here, this circuit with its protective timer. This green circuit I painted green, it's a single action circuit. It allows reclosing only one. Can be some models allow 2 or 3. They had not only timer but counter. Anyway, this in our case, this circuit allows operation of reclosing only if switch remained in on state approximately minute. In other way, it will not pass reclosing command. Also, inhibit auto reclosing command can be sent. This input allows inhibit command. We don't have pressure, something goes wrong. Okay, if we have arm signal, don't have inhibit, what will happen? What will happen? This signal will go, it's enable reclosing. Start reclosing, because we have on state, and this from here comes switch discontinued, start. But what's this? Switch is okay. One, it's a pressure circuit. We have sufficient pressure. This one, for example, has pressure sensor. And also voltage sufficient can be used. It's a tricky thing, but to prevent system problem, we will not perform auto reclosing if bus voltage is not sufficient. We will not increase load in emergency state. So we have start, switch okay, voltage sufficient, enable from single action circuit. This tone timer performs a auto reclosing delay. After reclosing delay, what happens? Signal is sent do auto reclosing. This one is a special relay. We did send reclosing command. It's a nice indicator. We had auto reclosing. And what then? Yeah. What's this circuit? Why we have goes there and up? What's this one? Can you see it? Oh, here it is. What's this one? In early version, it was kind of specific relay. Relay which holds command. Two versions existed. One here, early version of switch connection relay. Quite monstrous. It has a large contact to go. And also this copper kind of barrel. What happens when command do it, switch it on, comes, it connects this large contacts. It should send approximately 5 amps to our switch. But also current, magnetic flux fall to the barrel. If our signal to do the switch disappears, magnetic energy here, this relay will hold contacts approximately a second, or maybe longer. So this thing ensures switch on pulse, even if our I saw it in reality when switch command goes and relay goes to rest because of ANC incompatibility. This monster will keep signal on. Actually, it's a pulse format. We can send short pulse. Connect. This thing will convert it to long one or longer. Do it serious. Another version, wait, yeah, this was early version. Later, this kind of thing. No, this one has only it's one coil and copper barrel, and this. 1 second. Later version had 2 coils and barrel. Two coils. Oh, come here. Yeah. This one with 2 coils. 1 coil and second coil. Two coil version will hold command switch on until switch really switches on. So this circuit, when command do it switch on comes, it's set this trigger and it will hold auto reclosing, it's from Latvian, automātiski atpakaļ ieslēgšana. It's auto reclosing command, it will hold until signal switch is on arrives.
And now what here? What's this circuit? We have on command, we have command do auto reclosing. It will go this way. Here, this element prevents reclosing if signal from protection or from manual disconnect exists. If protection keeps sending signal do not connect, nothing will happen. And this logic ensures what? On signal will go through only once, and second one can be sent only after disconnection. It's a logic preventing auto reclosings, second multiple reclosing, or multiple on-off when signal on is held. Switch is pushed or remote dispatch system keeps signal. This circuit will prevent multiple on-off. Switch is on by command, off by protection, on by command, off by protection. No. On command, if there was disconnection from protection, can go only once. This circuit ensures. Nice logic. Really good stable logic, but it's usable only for radial lines. The problem if we have power sources from both sides. Problem in non-synchronous reclosing. If we have sources on both sides, it's possible what we will do reclosing when in worst case they are 180 degrees. But anyway, this voltage difference will make us problem. It will be serious heat. No, worst case in opposite. That means what there is an allowable range when we can connect two systems safely. We need to perform, when we are dealing with system, when we are dealing with situation when power can come from both sides, we need to perform synchronicity check or synchro check. Simplest way of synchro check in early days, electromechanical voltage difference relays were used. Idea. It's outer. Have a system like this. Coil 1, coil 2, 1. And this kind of anchor. This relay yields 1 if difference, vectorial difference 1 is less than set point set by the spring. Usually this relay, if voltages are 100 volts, get one in range approximately from 10 to 20 degrees. Can be adjusted. Simple, very simple. Check for synchronicity, but it's not enough. It's okay for simple line where difference in angle is nearly impossible. For line of serious importance, this will not work. Why it's not work? Because it don't have this relay. Don't have or do not ensure what? Check for frequency difference. In case we have inter-system connection, on the one side after fault maybe abundance of energy, on the other side deficit. This means that on one side frequency will go up and on the other side frequency will go down because we don't have enough energy supplied from our generation. In case we have a synchronous regime, there is a strict limitation on frequency difference or slide for reconnection. See, at the moment we connect switch, from the system where there is surplus of energy, huge energy flow will go to the system where is a deficit. They should rebalance. It's a mechanical heat. Only within limited range of slides this can be done. We need to perform simulation and we need to be sure what the resulting system will be stable, or otherwise we will destruct everything. So reclosing can be performed not only within limited range of delta angles. It's not enough. Frequency difference should be within limit. Please, my 1 second, I will find. Here. Go to hell. Here is, can you see it? Yeah. Auto reclosing logic with synchro control. Really. Real logic with synchro control. What's the idea? This reclosing logic, first, it has master-slave switch. What's the idea? We are here, system to system 1 was false, both switches are disconnected. Someone need to start. We need to perform reclosing of this line. Someone need to start. Master set should go first. For master waits for the reclosing, and then when it's possible to switch on. Conditions are all buses, this voltage is greater than 0.8 per U. All line is less than 0.2 per U. Why it's done? First, we have voltage here. We can do reclosing. If there is no voltage, we will do nothing. And second, we check what line is not energized. 0.2, 0.1, something like this, to prevent false separation from noises. Why? 0.8, 0.9, something like this. Why this check is? If master see what line is energized, that means what this switch is failed, and go to hell, we will not perform auto reclosing. If these conditions are met, master performs auto reclosing. Only slave waits for line voltage to appear. For slave operation, all buses greater than 0.8, 0.9, all line also should be greater than 0.8, 0.9. Two conditions. When slave sees this condition, what it's doing, it checks for delta U, the voltage difference here, vectorial difference, less than something like 0.1, and it should check for delta omega. It should check difference in frequency or check for slide. Only if frequency difference is within allowable range, reclose command will be done. So how it's work? In case of master, there are two voltage relays at AB and BC at line voltage. This prevents false condition ready when we are in asymmetric regime. All the design checked for only AB, for one line voltage. Average design checked for two. Most safe design checks for direct sequence voltage. Anyway, bus voltage should be greater than 0.9, and for line voltage, these two sets checks what AB and BC are below 0.2. This for master, this circuit allows auto reclosing. Then what happens? We are ready also. Switch is okay. Check for switch is okay. Start on difference. Start what last command do not correspond to switch state. The same thing. And then goes through this timer, activates this timer. After time of auto reclosing, through pulse forming trigger, goes as in previous version. What happens in slave mode? Slave mode more complex. In case switch is on slave position. See, it's a good practice. Periodically switch roles because master switch is loaded as much more aggressively. On persistent fault, master switch will disconnect for full short circuit current. Slave works in mighty conditions, so it's good practice to periodically switch roles. Okay, we are talking about the slave one. Signal bus voltage is sufficient. Signal line voltage is sufficient. Bus voltage check, line voltage check. Direct sequence. This double relay or it can be direct sequence filters ensures what we are in symmetrical regime. In non-symmetrical regime, this network do not operate. So, okay. We go here through this line. We go to switch. Okay, we check what switch. Okay, we have a start. We go ahead and ops. What's ops? What is this? We have a second timer and kind of logical network. Signal what we are in slave mode. Signal what voltage condition is met. Signal from logic and something specific. This relay. It's a synchro check relay. It calculates absolute value of difference if you, for example, have this is, let's say, 1, this is 2. Here is our delta. This difference, delta U, can be written as a square root 1 square plus U2 square minus double U1 cosine of delta. Or this is constant, this is constant. If voltages are constant, our acting is double U1, U2 cosine, but what is delta is a function? Omega 1 minus omega 2 times. That's what's under our root. Delta, this one rotated as omega 1, this one is omega. We will see so-called beat. Absolute value will give us something like this. It's an absolute value of delta U. Goes to 0. This one is time. And it depends on delta frequency difference. So if you, this is the threshold level of, in my case, 0, 2. This is threshold level. Output signal from a relay will be nothing, 1, back, 1, nothing. Understand why? This thing is like absolute value of cosine. Some scholars prefer to derive it into square of cosine. It's a difference voltage. This blue line is a threshold of difference circle. This what will be 1, 2, 1, 2. At a moment it is 1. Where is my tiny delta, this green line? It activates timer. This timer sets, no what? It's check for this time. For example, if I say it like this, check time, what will happen? In first case, 1, it check, still 1. Command will be error. In second case, for example, this time, what will happen? Signal, the differences within error range will disappear and timer still not. In this case, reclosing will be forbidden. So it's check for the slide. By what happens? Time of this part of arc is compared to predefined time of synchro check timer. It's the way to check for the frequency difference. It's done like this for a reason. And reason, it is quite hard to measure precisely frequency in short period of time. So check for voltage difference works better. When simple, it can be simple two frequency relays, but it isn't easy to measure frequency precisely without long period, and we don't have a long time. So synchro check or check for slide is done with the help of differential voltage circuit and comparison of output signal of differential voltage circuit with predefined time of this timer. If longer, will operate. If shorter, will lock. This one is more advanced synchro check. Actually, it's a level of, it was cutting edge for 70s. This version isn't ideal. This version isn't ideal. BGV, as I draw it, 02, I made a tiny mistake. It will check. Oh, I just understood what I have less than. You see, I have the less than. And this means what if less than, I will get inversion. If less than, I will get inverse. Sorry. I will get this, and this period will be compared. I have less than. I just checked. Not higher than, but less than. For less than, this period, it will work like this. And switch on will be possible only within this time frame. I have less than, not high. But key moment time period is compared to predefined time. This yields us control over slide. It's good, but not enough for high-end lines. One thing for high-end installation, it's a call to minimize this difference between voltage at a connection time. To do so, one thing should be taken into account, and it's a switch operation time. Best idea is to send switch on command this in such way to get switch connected at this point at zero disturbance. To do so, high-end recloser logics do take, they have two borders, trip 1 and this one trip 2. They extrapolate when, in some way, when the 0 point is, they solve an equation and send on command with so-called ahead time. They need to solve an equation to send switch on command in such manner what switch contacts, circuit breaker contacts will close in this moment of time. So they usually use two trips to estimate speed, rate of change of differential voltage, and this way they extrapolate when the 0 voltage moment will occur. This minimizes the negative effect. But this one is simple. High end of auto reclosing is so-called SPAC, single phase auto reclosing. What's the idea? Most of the faults are line to ground, single line faults. The higher voltage, for example, for 300 feet, approximately 90% of faults are line to ground. It depends from distance between phases. For 750, I'm expecting 99% will be line to ground. In case we have line to ground fault and we have a line, relay system interconnecting line, for us it's preferable to disconnect only faulty phase. This will allow us to keep some power transit between systems, and this will seriously increase stability. Systems will not desynchronize, they will remain in synchronicity. But to do so, we need a very complicated reclosing logic. Because how it works? We have signal from protection. Next, it's a set of distance relays UA, EA, UB, IC, plus they all should receive I0 phase selectors. Selectors of faulty phase. From protection, from phase, from protection, from phase, from protection, from phase, AAE logic. Typical AAE logic, but that's not enough. Okay, from protection switch state AAE logic. That's not enough. Actually, I can abandon this. See, there's a problem. This needs selector 2 from 3. I can do it like this. Will go only if not. This is kind, sorry, I don't need this. Kind 2 from 3 selector. These things allow us to operate in single phase mode only. Wait 1 second, it's no. This one should go here. This one should go here. Yeah. And not one of these, and operates if this one and non-B, non-A. Yes. This is selector called circuit 2 from 3, or it's a circuit that checks what we have fault only in one phase. If we have fault only in one phase, I logic starts, it sends signal okay, CPA CB for B phase, CB for C phase. In case only one phase, this thing has own set of phase selector. They are distance relays designed to produce one only if false is on own phase. So if A phase selector triggered gives us 1, B and C 0, only in this way we will have 1 here. From array logic will came signal to it, and for CBA signal will appear. If not, what will happen? What will happen? BTV is not wrong symbol. These are and. What will happen if not? If not, this will not work, and we will have free phase of disconnection. Disconnection also goes and simplify, because disconnection signal from protection also it goes through switch state. Wait 1 second. E. This is AAE first stage. In case of first stage, single line disconnect will happen. In case we have second stage or this not met, AAE auto reclosing second stage acts the same way as the signal from protection. It acts the same way. We get 0 here, nothing will go here, so we need 1. We're getting 0 here, and from protection we have second stage, and we have signal from protection. This creates signal disconnect O. It acts as a free phase. So if we have second stage or we have line-to-line fault, all brackets will be disconnected. So key moment selectors and logic allowing to single line operation, it's disconnect single phase. And auto reclosing will be performed on second stage. I need to draw auto reclosing. It's a huge one. One of from all these devices, Spark is most complex. This one more thing about Spark. If you have A, B, C phase, shunting, reactors on your line, they are compensating line capacity, shunt reactors. It's 550 kilovolts, something like this. For maybe shunt reactors to compensate your line, what will happen? You have, for example, fault, it's disappeared, switch is disconnected, but through line-to-line capacitance, voltage can be to line-to-line capacitance can supply enough energy what in this contour line capacitance, shunt reductor, inductance will remain resonance oscillation. And this will keep secondary arc at a fault place. So spark devices for such a line do one thing. They check line voltage for presence of oscillation signal. Some design do send disconnect signal to shunt reactors. Even exist versions where earth links are activated. If oscillation signal present, earth link can be activated here. So spark width check for shunt reactor oscillation. Complex thing.